So often you will be given a polygon with diagonals inside. The diagonals produce isosceles triangles, trapezoids, or pentagons. Okay. So, so if you have an isosceles triangle, to recall that, that would simply mean that two sides are going to be equal. Therefore, the two base angles are the same. We can call them B, and the top angle will be A, right? So if you know A, to find B, we would just go 180 minus 1 times A divided by 2. And there's a reason why I do that, 1 times A. And I'll make a note about A in a bit. Let's cut this here and have the isosceles trapezoid. It goes like that, and isosceles trapezoid has these two sides the same, and therefore the angles at the base will also be the same, just like an isosceles triangle. And you have these two angles being the same as well. Okay, if it's an isosceles trapezoid, which will be the case for us. So to find the base angle here, we would go with a triangle. The sum of angles in a triangle is 180, correct? The sum of angles inside a four-sided shape, what would that be? Quadrilaterals is always 360, right? So we would go 360 minus 2 times A. And we will divide that by 2. Now I'm going to say something here. I'm going to add something because I see a lot of mistakes being done right here. Okay, 1 second. Somebody said something. Okay, Pearl. Okay, good that you're here. There are invisible brackets always. Whenever you have stuff happening in the numerator or denominator for that matter, you should make sure, right, that you take into account that you need to first figure out what the top is and then divide by 2. Don't do it in one shot because it's going to be wrong. And then you're frustrated because it's going to be a lot of work that's down the drain for you. Okay. Next, we're going to do, are we going to do an isosceles pentagon? Yes. Let me try this. So let me do it first, and then you do it, okay? So I'm going to start with a triangle like this, like a roof. And then we're going to make this a little shorter. Something like that. Where this side is kind of like cutting off. It's not like your regular pentagon. These are isosceles pentagons, okay? So you've got these two sides being the same. Therefore, B, actually, all sides here will be the same in this case. got B, and you've got A, and A. So to find B in this case, you will still divide by 2 because you're going to split the difference in between the two B's there. And the sum of a 5-sided shape, what would that be? Use the formula. Sum of a 5-sided would be 5 minus 2, which is 3 times 180. That's 540. Okay, that's basically what I did with all of them, except for we already know that if it's a 4 or if it's 3-sided, it's 180, it's 360. It'll be 540 minus 3 A's that are up here. And I'm going to put the brackets around that. All right, so now that this is going to be useful when we will recognize these shapes inside a polygon. Okay, that's where we're going with this. So I think before I continue, I will just pause the. Aha, I almost forgot to record. So here we have this hexagon, and mind you, it's a regular hexagon, so I will tell you that, right? So let's go ahead and make these marks. You're guaranteed that they're all the same. Didn't have to, but for the most part, we're talking regular. So we're going to make this A, okay? This is the question A. So focus on the exterior shape first. Okay, so we count hexagon, right? That means that n is equal to 6, right? Find the interior angle using in is equal to n minus 2 times 180 over n. Okay, we're going to use this formula to come up with the interior angle. No matter what, that's your starting point. Okay, you want to find out. They happen to ask for it anyways, but even if they don't, you're going to have to do that. Okay, so the interior angle of a hexagon, I'm sure if you've done your homework, you will know this already, that it is 120. A is equal to 120 degrees. I'll just say happens to be the interior angle. So A is taken care of. B is the base angle of an isosceles triangle. Therefore, B is going to be 180 minus, in this case, there's only one. Think about it, right? Like there's only one angle that you need to take away from 180, and then divide the remainder in half, because they ask you for this, but really they are both the same. This could have been X, Y, Z, it doesn't matter, right? So we're going to go minus 120 divided by 2, put that in brackets, so that's 60 divided by 2, which is 30 degrees. And I will tell you, we will bring this up here and add a little diagram to aid in your understanding. Okay. If these two are the same, then this is the same as that. And this is the 120 that we calculated earlier, which is that A there, okay? That is the apex or the top angle. And that's what we've done here, okay? We've calculated when 180 minus the top angle divided by 2 to give us 30. So B is equal to 30 degrees. And now we have to find C. Well, if you think about it, C and B combined make up the interior angle of that hexagon, right? And then C is going to be equal to the interior angle of hexagon minus B. So C is going to be, we know that the interior angle of a hexagon is 120 minus 30, and that's 90 degrees. Because again, it goes back to B and C adding up to the interior angle, right? So whatever the interior angle is, let's say this is an octagon, I think it's 135, right? Then you would just go, okay, I know it's 135. I'm going to subtract whatever B is in this case, could be X, Y, Z, it doesn't matter, right? And then get what is left, right? Because combined, they should always add up to that interior angle of that shape that is like encompassing everything. Okay, so there's the combination of outside, right, like the big pentagon, and the inside shape that has resulted from that diagonal that has been drawn. Okay. By the way, this C would be the same as this angle across from it, because also, like, there are basically two shapes here, right? And so this is also an isosceles something. 1, 2, 3, 4, 5. It's an isosceles pentagon, by the way, right? So you also know that this would be the same, but they're not doing that in a question like this. They're just asking for that specific angle, hoping that you will know you have to divide it in half, okay? Okay, I'm going to have more examples. When it gets crazier than this, I will give you a handout. I will point you to a handout that has them drawn already, because right, good luck trying to draw a decent octagon, right? So our examples are going to stick with shapes you can draw. So let's do a pentagon here, right? We go like this, and go a bit an angle like that, and cross like that. And we're going to do cross here, like that. And we're going to add a second diagonal, like this. to call that X, Y, I'm going to call this Z here. X, Y, and Z. And I lied to you. I said no octagons. I think I'm going to add an octagon here. A, B, C here. Octagons aren't bad. So you start like this, almost like a hexagon, except for you add a straight vertical section to it. So this is your top, and then you go down like this. And I'm using 2 rows, 2 lines down like that. And I'm going to try to make it symmetric, so I kind of just come down here and just make a very, very light line like that, and then I connect. Folks at home, were you done with B or no? I'm going to go back to B a little bit. There. All right. Let's do this one first. We've got a pentagon, so n is equal to 5. Make a note of that. I know that x is the interior angle, right? So x is going to be n minus 2 times 180 divided by 5. And that I know is 108. So x is already determined, but even if they didn't ask you for it, this would have been your first step, okay? So x is the interior angle. Interior angle of pentagon. Okay. To get y, you should realize that this is a triangle and it's an isosceles triangle. You can go ahead and make that assumption. So y is going to be 180 minus the 108. In this case, it's 108 at the top, right? Minus 108 divided by 2. And I go ahead and make sure this is in brackets, right? That would be 72 divided by 2. So y is equal to 36 degrees. So I found x, I found y, and now I need to find z. Question. Is this triangle here the same as this one there? I know our drawing is not the best, right? My drawing, you can say it, right? It sucks, right? But we know that this pentagon is the same all throughout. So whether you go from here and create a triangle there, or if you go from here across and create this triangle is the same as that one. Okay, I can guarantee you that. So when we found out that y is 36, and that's up here, we actually also found that this is 36, and that this is 36, and that this is 36, right? You found the base angles of all the triangles that can be created using the exterior sides, that is, okay? If you use any two exterior sides to make your triangle, you're guaranteed because, right, this is 108 here as well. So think about it, you would subtract 108 from 180 divided by 2 and still get 36, right, no matter what you do. So how would you find Z, right? Well, we know that Z would have to be 108 degrees, which is the interior angle of this whole pentagon here. Subtract 36 from it, okay? Because you got to take 36 away from 108 to get Z, okay? And what are we at there? 72, right? Yeah. 72 degrees. So I kind of tried to make you see that, right? There could be diagonals every which way, but sometimes it isn't a whole lot of work if you just realize, oh, okay, it's the same triangle, okay, that is formed. So if I took a diagonal from this vertex and went across like this to this vertex here, I'm still using two sides of that pentagon to make it, so that triangle would also have the same angles as the two that are visible there. Careful, the one that's here is not the same because two are not the exterior sides, right? Those are two diagonals you're using to make it, so this one isn't going to be the same. Okay. All right, let's go to our octagon. And I'm going to cut it like this, watch. I'm going to go from here to here. And what more? I'm going to extend this side here. I'm going to make it dashed, okay? And I'm going to extend this side here and make it dashed to make a little triangle out here. And we're going to ask you to find A, B, C, and D. Okay. I'm going to ask you to do that, to give that a try. C, maybe you park that for a bit. Park C for a bit. Like, you don't have to do that right away if you don't want to. But try to find A, B, and D right now based on what we've done. See if you know how to get there. Knowing that I will go over it, but you need to get your feet wet, okay? And then I have a worksheet. You can look for this one right here that I'm going to assign you after. So take some time and try that. I'm going to pause the recording. So to find A, first of all, you realized 1, 2, 3, 4, 5, 6, 7, 8 sides, right? So n is equal to 8. That's important. Don't worry about this yet, right? Just count the outside, and it's 8. So that'd be 8 minus 2 times 180 divided by 8, right? So that'd be 135, right? Yeah. It's 135 degrees. You're done with A. B is a little trickier, right? So we count 1, 2, 3, 4, and the diagonal 5. So that is a pentagon. Okay. B is the base angle of an isosceles pentagon. That means that almost all sides are the same. Okay, so if you want to look at it this way, right, you go long side and then you go up, over, right? So you've got 1, 2, 3, 4, and then 5 here. So B is there. How many angles are up on top here? Those are all technically the same as angle A. So this is 135, 135, and 135, right? Like that. And technically, if this is B, then this is also B, right? These are going to be the same. So to find B, we would go with the whole thing. The sum of a pentagon is 540, okay? So those formulas, those 3 that I gave you, have that on your study sheet, and then it's a lot quicker. So that's minus 3 times 135. There are 3 angles, 3 interior angles of that pentagon that we just sliced, right? I think this would do a lot better if we actually had like a pizza, like an octagon pizza. To do this example, I think you would learn a lot faster, right? So you divide it by 2, and you get 540 minus 3 times 135. That's 135 divided by 2, which is 67.5 degrees. Make sure this top is in brackets, or do that first and then divide it by 2. So you found B there. Okay. Now let's worry about angle D. D is found by going, we know that this whole thing is 135. Right? So we just go 135 minus angle B. So D is 135 minus 67.5. Which is 67.5, right? This happens to be half of 35. It actually slices it exactly in half under these circumstances, but don't always assume it's the same, right? So that's D. How about C here? Allow me to try to enlighten you here. If this is, we know that this is 135 and this is 135. Oops, 135. Right? They're all 135 all around. What do we call that angle that's created between the vertex and the extension of one of the sides? We call this the exterior angle, right? And here we have an exterior angle too. So I'm going to just say that and this are exterior angles, right? They're exterior of the octagon. So we know that these two add up to 180, right? So we know that this is 45, and we know that this is 45 also. This will be part of your explanation. If you want to show me, like, 45, 45, you write it right into that diagram. That's fine with me. So angle C is going to be, this is a triangle, by the way, 180 minus 2 times 45. So angle C, which kind of looks like it anyways, is going to be 90 degrees. So this is basically related to that little extension that comes out of that octagon. Okay. All right. That's it for today. The homework worksheet called Polygons with Inscribed shapes. Okay. And it looks like this. So let's watch the top here. Right, it looks it's like a double-sided, one single sheet. And just 1 second yet, and I'm gonna make sure it's recording so it's on record. I'm gonna quiz you on this next Tuesday. Okay, not Monday, Tuesday, which is the 3rd. And I think group 2 is gonna be in that day. Okay, so group 2 will be writing it here. Everybody else will be writing it remotely. And so the quiz is going to be basically everything we've done in this unit. There's a little bit of quadratics, like short answer. So always have that in mind. So next Tuesday we're quizzing. Maybe I'll write it down here. Tuesday, November 3rd. And then you know where we're at. Okay, so if you have any questions, email me, let me know. This is a little confusing, but you need to work at it. You can't just say I don't understand it without giving it a try. Okay.